Hello everyone. In this video, we will review one of the most important concepts in mathematics, the quadratic equations. Quadratic equation has three forms. The first form of the quadratic equation is called the general form of the quadratics. In this form, you will have the full three terms on the left-hand side of the equation. Please note that the right-hand side of the quadratic equation always equals to 0. So note this, I have ax squared. Then the next term, I have bx. So I would like to write bx to the exponent 1. And the last term, I would like to write c times x to the exponent 0. Note that x to the exponent 0 is equal to 1. So the reason I point this out to everyone is to make sure everyone remember that we have x squared. The next term we have x to the exponent 1. And the last term we have x to the exponent 0. Quadratic equation has the highest exponent of x as 2. The number 2 will tell me that I must have two solutions for the quadratic equations. So the next form of the quadratic is called pure quadratics. In pure quadratics, you notice that you are missing the middle term bx, but the exponent is still equal to 2 in this case. Therefore, you must have two equal but opposite roots. The next form is called the incomplete quadratics. Incomplete quadratic, you are missing the last term c. You can solve for the incomplete quadratics by using factoring, and from factoring, you can find that one root must be equal to 0. So in solving for a quadratic equation, we have to use the quadratic formulas. So for x1 and x2, x1 is equal to minus b plus the square root of b squared minus 4ac divided by 2a. x2 is similar. The only difference is I will have the subtraction before the square root of b squared minus 4ac. In this case, I should have a plus of square root b squared minus 4ac. I would like to draw your attention to this expression b squared minus 4ac. b squared minus 4ac is called the discriminant. The discriminant is the key and is very important to figure out in solving for the quadratic equation. b squared minus 4ac will tell me what type of solution that I'm going to get. So if you take b squared minus 4ac greater than 0, the roots are real and unequal. If you calculate b squared minus 4ac and you found that it's equal to 0, the roots are real and equal. b squared minus 4ac less than 0, the roots are complex number. So let's go over a few examples. The first question I would like to go over is the pure quadratics. 4x squared minus 122 equal to 0. It is the pure quadratics. So in order to solve for this, still follow the same concept of solving for an equation where you have to isolate x. So I have 4x squared equal to 122 on the other side. To divide both sides by 4, I should have 122 divided by 4. So x squared is equal to 30.5. Okay. With pure quadratics, I will have two equal but opposite roots. So I will take square root on this side of the equation. I do the same thing on this side, but I must have plus or minus of the square root of 30.5. So in the end, I will have x equal to plus or minus 5.52 if you round this to 3 significant digits. Alright, so let's move on to number 2. In this case, I have an incomplete quadratics. So let's write it down, pure quadratic. This one, I have incomplete quadratics. As I mentioned earlier, In working with incomplete quadratics, the best way is to factor. So note that I have 7x squared and 42x as a minus. So I found that 7x is a common factor of both terms. So I factor out 7x. Inside the bracket, I should have x minus 6 equal to 0. So let's analyze this. Okay. Here you can see that you have 7x. You multiply that with x minus 6. So you have a product of a term and a binomial, and the result is equal to 0. Then for something to become 0, and you multiply these two together, so one of this has to be equal to 0. But we don't know which one. So we are going to analyze it as 7x equal to 0, or I can have x minus 6 equal to 0. So if 7x equal to 0, obviously x has to be equal to 0, and x minus 6 equal to 0. The solution is x has to be equal to 6. Alright? Okay. So let's move on to the next example, where I can have the full or general form of the quadratics. In this question, they asked me to try to solve for this quadratics using factoring. So let's try that. Okay. To factor, the first step is to take 10 times negative 18. Okay. So 10 times negative 18. I should have 180 as a negative. Then I must find two numbers, and the product of two numbers will give me negative 180s. The sum of that same two number should give me positive 3s. Okay, so I found that I should get negative 12 and positive 15. So if I take negative 12, add 15, I should get positive 3 as the answer. So the next step is to break the middle term 3x into 2. So let's rewrite this. 10x squared plus 3x minus 18 equal to 0. I will break this middle term 3x into minus 12x plus 15 x minus 18 equal to 0. Then I group the first two. I also group this 2, and I pull out their common factor. So in this case, I should have 2x as a common factor. Inside the bracket, I should have 5x left over minus 6. This two term, I should have 3 as a common factor. Inside the bracket, I have 5x minus 6 equal to 0. Now I can see that I can have the same binomials as a common factor. So I can pull out that the common factor 5x minus 6. Inside the bracket, I left with 2x plus 3. So equal to 0. From here, you can pull out that 5x minus 6 equal to 0. So x is equal to 6 over 5. Right here you can have 2x plus 3 equal to 0. Therefore, x is equal to negative 3 over 2. So these are the two solutions for this quadratic equation. X equal to 6 over 5 and x equal to negative 3 over 2. In this example, they asked me to try to use the quadratic formulas. Okay, so let's work with that. In working with quadratic formulas, it's very important that you identify A, B, C and identify them correctly. So A is 10, B is 3, C is negative 18. And what I will do, I want to calculate my discriminant first because I want to find out what type of solution that I'm working with. So B squared minus 4AC, so it's 3 squared, subtract 4 times 10 times negative 18. So in this case, I should have 9 plus 720, so equal to 729, which is a perfect square. Okay, so let's find x1 will be equal to minus b, which is minus 3, plus the square root of the discriminant divided by 2 times a, in this case is 10, so I should have minus 3 plus 27 divided by 20, so I should have 24 over 20. You can reduce this to lowest term by dividing the numerator and the denominator by the same number 4, then you end up with 6 over 5. Okay, so for x2, what I have is I should have minus 3, subtract 27 in this case, so it's over 20, so I have negative 30, negative 30 over 20. I will divide the numerator by 10, divide the denominator by the same number 10. I should have negative 3 over 2 as a solution. So we have the same solution as we did in number 3. Okay. So let's move on to the next example. Example number 5. In this question, you see that you don't have an obvious quadratic equation to work with. However, if you expand the brackets, then you can see that you end up with a quadratic. Alright, so let's do this. I have x squared, subtract 7x, equal to 2x squared, subtract 12x plus 25. So working with quadratics, the other side has to be equal to 0. So make the left-hand side equal to 0 in this case. So I will move x squared, subtract 7x over to the other side. So 2x squared, subtract x squared, subtract 12x, plus 7x, plus 25. Collect this 2 term, I should have x squared. Collect this 2 term, I should have minus 5x, plus 25. So this side equal to 0. So let's work with b squared minus 4ac to see what type of the solution that we are going to have. So here a equals to 1, b equals negative 5, c equals 25. So b squared would be the entire minus 5, all of it squared, minus 4 times 1 times 25. So in this case, I have positive 25, subtract 100, so I end up with negative 75 is less than 0. So therefore, I have complex solution. Okay. Having complex solution, I want to remind everyone that remember j equal to square root of minus 1. This is very important. We will apply this in solving for the solution for this quadratic equation. Okay, so now let's work with x1. x1 is minus, that means minus of minus 5, plus square root of negative 75 divided by 2 times 1, so in this case it's just 2. So I want to write it as positive 5 plus, I will break the square root of negative 75 into square root of negative 1 times square root of 25 times square root of 3. Okay? Because negative 1 times 25 times 3 could give you negative 75. The reason I'm doing that is because square root of negative 1, I turn that into j. Okay, so here plus j, square root of 25, I should have 5, and I rewrite square root of 3, the whole thing divided by 2. So in the end, x1 is equal to 5 plus 5j root 3 divided by 2. factor out the 5 over 2. Inside the bracket, I should have 1 plus j root 3. Okay, so this is one of the solutions. From this solution, I can pull out x2 equal to 5 over 2 and 1 subtract j root of 3. Alright. Okay, so we have one more example to go over. This example right here, where I have fractional equation. It is a fractional equation, and if I modify this or simplify this, I will end up with a quadratics. So for quadratics, the best way is to leave one side equal to 0. So I'm going to move this over to the other side of the equation. So we have a subtract 4 over x minus 4 will give me subtract 9 addition of x over 7. Before I move on, I would like everyone to remember that I cannot have x equal to 4. So this is the restriction. Because if I have x equal to 4, then if I substitute into this denominator, I will have an undefined condition. So it's a good idea to check it out first before we move any further. Okay, at this point, I'm going to write x plus 7, x over 7 here as a plus, then subtract 4 over x minus 4, and I have a subtract 9, so I should have minus 1 in this case. This is still equal to 0. Okay, so let's work with the lowest common denominators in this case. Okay, so I will have 7 times x minus 4. So here's 0. I have 3 fraction to work with. So I will write 3 fraction. So I want to achieve the same denominator for each of this fraction. Okay, so I perform the step called equivalent fraction. So I want you to note this. Okay, here's your first fraction, which is x over 7. But then you turn that into 7 times x minus 4. Okay, it means that you must multiply x minus 4 to the top. Okay, so keep that in mind. So in this equation you have 4, but now the bottom you have 7 x minus 4. The original one you only have x minus 4. That means you multiply by 7. Therefore you take 4 times 7. Okay. The last one is in fact 1 over 1. Then you turn that into 7x minus 4 as a denominator. It means you have to multiply the denominator and the numerator with 7x minus 4. Alright, okay. A quick review for everyone how to take lowest common denominators for each of these fractions. Alright, so let's write everything as just x minus 4, subtract 28, subtract 7, x minus 4, the whole thing divided by 7 times x minus 4. So at this point, I would like to get rid of my denominator by multiplying both sides by 7 times x minus 4. So on this side, you have 7 times x minus 4, so it's also equal to 0. So but this enables me to cancel the denominators. So now I end up with 0 equal to x multiply x minus 4, and then subtract 28, subtract 7, x minus 4. So let's multiply each of these terms inside the brackets. Then I should have x squared minus 4x minus 28 minus 7x plus 28. Okay, So collect like term, I see that cancel with that. I have x squared minus 11x, and this is equal to 0. So you have an incomplete quadratic in this case. Incomplete quadratics, we should factor out the common factor. So I should have x minus 11. In this case, I should have x equal to 0, or I should have x equal to 11. And we are done. Thank you.